We are actually in Backtrack. This is a screenshot of a tool that I love. Even if I'm not cracking WEP, this tool is great. This is the main screen of Kismet, and as you can see, I have SSIDs here. So all of the names of the networks that are in range. Note that I've never vetted these networks. This is just like if you open Windows and search for wireless networks. Same concept. Then you have some columns here. Not quite, can't quite remember the T. The W is the type of encryption. So for instance, JJ Wireless is Y, which means yes, it's WEP. O, I believe, means open. That doesn't necessarily mean it's unprotected. It could be WPA or WPA2. So this column is more just a WEP type detection. This is the channel. Like I said, commonly you're going to see 1s, a lot of 5s, 6s, and 7s, and 11 is really the most common. So for instance, these 5 networks are all on 11. And if they're all close together, you're going to get a lot of interference. Because like I said, wireless routers broadcast everything everywhere. And so packets are literally flying through the air. You're going to have a lot of collisions. So if you have interference problems, go ahead and change the channel. Get away from that. Packets, it's just the number of packets it's seen on that network since I started monitoring. IP range, this will only be available if the network is open and unencrypted. So if you have an unprotected network completely, it'll be able to tell you what kind of IP address scheme that is being used on that network. But like I said, most of these are protected, so we can't see that just yet. This is still Kismet. What I did was I selected a network called Hack Me Please, and you can see just about anything you'd ever want to know. Like I just said, the IP type is not detected because it's encrypted with WEP. If you start at the top, you see SSID is Hack Me Please. Don't bother with the server. BSSID is the MAC address of the wireless access point, so the actual device identifier for the antenna is the BSSID. Carrier will tell you what kind of wireless standard it's using. So BGN are the common ones that you see now. You don't really see B anymore. Does anybody have N wireless at home? Your card does.
I do. I have the Apple Airport. And I'm pretty sure, yeah, this said that it doesn't.
Yeah. So that's basically all that is. It's a specification. IEEE comes out with new wireless specifications. The wireless specification for wireless internet being 802.11, and then the G or the B or the N or whatever you have at the end is a type of that. So they come out with new revisions. G, basically the biggest difference is not only signal strength, but let's take G. The maximum bandwidth that you can have, meaning the megabits per second on G was 54 megabits per second, which isn't shabby. I mean, it's not nearly as fast as plugging in a gigabit switch or anything like that, but it's not too bad. N is 270. So it's a pretty big leap. But as you can see, they only support B and G. So that'll tell you a little bit about their network. Not necessarily. I mean, nowadays N is kind of commonplace. You're not going to see a lot of people with N not being tech savvy, that kind of thing. Encryption, WEP, channel 11. We've seen all this. But all of this information is very useful for reconnaissance if you want to see what you're looking at. Let me go back. There's a couple things we need to remember. Kismet, like I said, is a tool for just doing reconnaissance. It doesn't do anything. It reads. That's all it does. But there's some cool things you can do. First of all, if you want to use this tool, I recommend sorting by channel. If you guys really want to write this stuff down, push SC. That'll sort by channel, and I've done that 1 through 11. And that'll make it easier to use, and actually you'll be able to select it at that point. So the next screen where I saw the details, I actually scrolled down to Hack Me Please and enter. Other thing, capital L will lock your interface onto whatever channel, whatever channel the network you selected is on. So for instance, if I have this network highlighted and I push Control L, it'll lock the interface onto channel L. What that means is it won't be scanning for multiple channels to look for different networks, because normally it is. You want to be able to scan all those channels for different networks. Locking it makes it less noisy, so to speak. So it's a useful tool to know if you want to use Kismet to lock onto your target. Then we'll continue. This is going to be, I'm starting a basic walkthrough. This walkthrough is readily available on YouTube. In fact, that's where I got it. This will show you how it would be done. So arrow dump, we've got a couple arguments here. it basically, this command will basically configure your interface for locking onto this network. You're basically telling it it's a web network, it's on channel 11, and here's its BSSID, and use wireless LAN 0 as the interface you want to use. And remember, BSSID we found in Kismet, so that's a tool you can use. You don't have to use Kismet, you can use other commands to find out this information, but you will need to know BSSID and the channel and the interface. So that's what that command does. Before I go on, this field data, it will be important later. Yeah, and then actually this command performs the injection. This is where the injection takes place. Can't do anything with it yet, but that's where it happens. This associates your wireless card with the access point, so it it locks that on. And then here's where we're actually capturing the responses. Like I said, the two previous commands did the injection. Now we're capturing responses. So at this point, we're building a file of comparisons. And it's traditionally a CSV file for those comma separated values, pretty standard format. It also does IDS, Linux kind of stores everything as text files. But this is where you are saving it, and it'll actually tell you saving ARP requests in and then the file name, and that will be our capture file that we'll crack later. And then here is the actual crack. Once you have that file, depending on your methods, the method that I showed you, if injection is enabled on your card, maximum of 5 minutes, and the network is yours. So it's not shabby, but again, injection is required. This is aircrack. The command is aircrack-ng, no caps. And then after that, one argument, and you tell it the name of the file that you want to crack. So, I told it the name of the file that we were given in the last command, and it went through and compared all of those keys side by side by side, and it said, this is the key, because of the comparison between the two. And that's it. Now you have the key. So, let's go ahead, and I'll show you the method that I've been using, because I do not have injection available to me on this PC. It's kind of old. So, what I was going to do, what I've done to get around the issue of packet injection, if you can't do it, first of all, the only pro to, not only one of the pros to having packet injection is doing it really quick. Packet injection will allow you to crack a web network in about 3, 4, 5 max minutes. What I do traditionally is I run air replay, which is the first command we looked at. What that does is it sends out the requests. It's not packet injection. It generates traffic on the network, and that does it repeatedly. So it's kind of a looping process that I let go once it's done. And I give it all the information we saw, so BSSID, all that kind of stuff. So it's really not too different. And then at that point, I run air something. That captures the replies, much like we did after the packet injection. And that saves it to a file. Aerodump, that's it, aerodump. And that captures the replies and saves it to a file just like we did. And then at that point, I can let it sit. And what happens is the IV packets that I told you that are the holy grail of this that we need, those will be generated whenever the network requires them to be generated. Meaning that we won't be generating them, because with packet injection we are. That's why it happens so quickly. But this way it's a lot slower, so whenever the network decides that it needs to generate IVS packets or IV packets, then it does it. That's why it takes a long time. However, there are some things we can do. Air replay provides a couple attacks that you can do. My favorite is deauth. What that does is it deauthenticates basically all the devices in the network. Normally that's not an issue because deauthentication can be fixed